Okay, I'm back to talk some more about confidence intervals. So in the last video, we talked about point estimates, and the point estimate is just the statistic you get from your sample, the standard error, which is going to be different depending on what type of parameter you're estimating, whether it's a mean, a proportion, a difference between mean. But that standard error is always going to factor in creating confidence limits. And the confidence limits are the upper and lower values within which you have a certain amount of confidence that 95% of the time, 99% of the time, that the actual population value falls. If you get a mean of 190, like we saw in the last one, that your confidence based on the number of people in your sample, and the standard deviation might be somewhere from 187 to 203, something like that. And that's pretty much how you interpret confidence intervals, that this is the range within which we are pretty confident that the actual population value falls. Last time we looked at the confidence estimates for the mean, so let's look at something else. We already discussed this, the sample mean plus or minus z times the standard deviation of the square root of n, which is going to give you the standard error. Now let's look at proportions. The confidence interval for proportion, we're assuming you have a dichotomous outcome. You either are an English language learner or you are not. You graduated college or you didn't. You graduated high school or you didn't. You get the idea. So one of two possible outcomes. And you have one sample. So this is another kind of confidence interval we're going to estimate. So this P with a little hat over it that looks like an upside down V is the sample proportion. So that is our estimate of the population proportion. And how we find the confidence intervals is we take that sample proportion plus or minus Z. We have Z because we don't have any standard deviation here, right? Plus or minus Z times the square root of the sample proportion times 1 minus the sample proportion over n. That is how you're going to get the confidence limits. So estimate the proportion from the sample plus n minus z times the square root of the proportion times 1 minus the proportion divided by n. Now, again, we have some real data. 12% of Native American fourth graders are English language learners. This is also from the 2019 National Assessment of Educational Progress that we talked about in the last video. This time our N is 8,100, because in the last video we're just looking at our sample from South Dakota, but in this case we're talking about the sample that we had from the whole US. The sample proportion is 0.12, and 1 minus 0.12 is 0.88. So that's our P, 1 minus P. The square root of 0.12 times 0.88 divided by 8,100 is 0.0036. One 1.96 times, so this whole thing over here, the square root of p hat times 1 minus p hat over n is 0.0036, and 1.96 times 0.0036 is 0.007056. Keep that in mind. Then our confidence interval is going to be 0.12 minus 0.007, which is going to give us 0.113, to 0.12 plus 0.007. So in other words, our confidence interval for the proportion of Native American fourth graders or English language learners is 11.3% to 12.7%. With a sample proportion of 12%, which we found, 95% of the time, the population mean would fall between 11.3% and 12.7%. And you can see that that's a pretty small range. But the reason it's a pretty small range is we had over 8,000 kids in this sample, right? So you figure you probably get a pretty good estimate of the population value, assuming that it is unbiased.